Boom! Hume again. How are you going? So in this video, we continue with our discussion of factors, multiples, and primes. In the first two videos, we dealt with factors and multiples. We went through what a factor and a multiple is in the first video. In the second video, we illustrated the difference between the two. In this video, we're going to start talking about prime numbers. What are prime numbers? A prime number is a very special set. Sorry, a prime number is a member of a very special set of numbers. These numbers, what do they have in common? What these numbers have in common is that the only two factors are the number itself and the number one. Remember, in our previous discussion of factors, the technique we used when we were looking for factors was to look for it two at a time. We look for it in pairs. So that when we get to prime factors now, we realize there is only one possible pair of factors for a prime number, which would be 1 and the number itself. So in other words, those would comprise what we refer to as the prime factors. And we will deal with prime factors a little later in this same video. So let us just run through a few examples. I will go from 1 to 31 in this video, just as we did in a previous video. So in the previous video, I would have spoken it, I would have talked about it, but I didn't put it on the board. So we would have engaged the auditory sense in that video. So now we're going to bring the visual sense into play as well. Excuse. So 1, number 1 is 1 by 1. It have nothing day, as I was saying in the previous video. Number 2 is also, well, 1 by 2. Have nothing day. Number 3 is 1 by 3. Have nothing else day. 4 can be a factor because 4 is 2 by 2. So once we get out of this little zone here, 1, 2, and 3, where 2 is an even number and it is also prime, anything beyond this, your prime numbers will always be odd. The number 2 is the only exception to that rule for prime numbers. Everything else, your prime numbers will invariably be odd numbers. So at this point, we're not going to waste time considering 6 and 8, no, and 10. Even numbers. Forget even numbers for now. Let me stick with the odd numbers. 5. 5 is 1 by 5. It had nothing else there. Right? 7. 7 is 1 by 7. 8. 9. 9 is not a prime number because 9 is 3 by 3. 9 is a perfect square. We spoke about that earlier too. 11. 11 is 1 by 11. 12, no. 13, yes. 13 is 1 by 13. 14, 15, no. 15 is 3 by 5. So 15 is not a prime number. 14, 15, 16, 17. 17 is 1 by 17. Nothing else there. Right? 18, 19. 19 is 1 by 19. 20, 21. 21 is not prime because 21 is divisible by 3. 21 divided by 3 is 7. 7 3 is 21. Which means that 21 is divisible by 7 as well. Right? 21, no. 22, no. 23, yes. 23 is a prime number as well. Equal 1 by 23. 24, no, obviously. 25, 5 by 5, another perfect square. No. 26, no. 27, yes. No. 27 is 9 by 3. 3 by 9, so 27 is not a prime. 29, yes. 29 is 1 by 29. Right? 13, clearly not. And then 31 is 1 by 31. So we had stopped at 31 in the previous video and we will stop here. But as you can see, we could go on and on and on. Right? What's the next prime number for 31? Not 33 because 33 is 3 by 11. 34, not 34, 35 is 5 by 7. 36, not 36, 37. We don't have factors of 37. No. 39 is 3 by 13, so 39 is not a prime number. So as you go beyond this, you will start to get into larger numbers where you'll be required to be familiar with a larger range of numbers. But we will leave that for a separate conversation. That's basically it, you know. That is basically it, what a prime number is. So it sounds like something complicated, it sounds like something harder. But the nice thing about it is that after we go through the whole stress of discussing factors and multiples, once you understand what factors are, then it's just one half a step now to get into a particular subset of factors, which is your prime factors. So your prime factors, you only have two. One, the number one, and the actual number itself. So with that, we can now go into the issue of factorizing any number as a product of its prime factors. And you could do that with any number. Because any number that has factors, you could always break it down. And eventually, you will get to the point where you can't break it down any further. And once you get to that point, that would be the point where all the factors that you would have listed would be your prime factors. So let us go back to some of the numbers that we would have listed before, that we would have used in the discussion of factors to illustrate the point. We would have started with the number 36 when we were talking about factors. Alright? So let us first of all list the factors of 36, and then we will go one step further and list the prime factors of 36. There's a slight difference. So we're going to use the number 36 to illustrate that difference. So going back, and we're going to use the same color of ink just for consistency of visual recollection. We had 36 in orange, and we had it as 1 by 36. We had it as 2 by 18. We had it as 3 by 12. We had it as 4 by 9. We had it as 6 by 6. And that was as far as we could get, because after 6 by 6 is 9 by 4. And then we do the same thing with the number 54. Alright? We had 54 as well. So 54 was 1 by 54. It was also 2 by 27. It was also 3 by 18. 4, 5, 6. It was also 6 by 9. After 6 by 9 is 9 by 6. So we don't have anything more to say where that is concerned. So we had said here that the factors of 36 would have been 1, 2, 3, 4, 6, 12. Sorry, not 12. 9, 12, 18, and 36 itself. Alright? Right. So we leave that there. 1, 2, 3, 4. Right. And we had said that the factors of 54 would have been 1, 2, 3, 4, 5, 6, 9, 27, and the number 54 itself. Nice. Now, we enter the zone where instead of simply listing out all the factors we're now going to list the prime factors of each number. That is a slightly different exercise, so I want you to pay very, very careful attention. Just to recap, at this point, we hope that you are already comfortable simply listing the factors of any number that has factors. We use 36 and 54 as our examples here. There are other examples we will use as well. We're going to take the process a little further now. Having just discussed what a prime number is, we're going to now break down both of these numbers into its prime factors. Now, let me talk a little bit about the use of the word factorize. So, we know what a factor is. So again, let me get back into English mode now. So, factor is the noun, right? There's a verb that goes with that too. The verb is to factorize. To factorize as a verb. So in the same way that we had to multiply as a verb, and then you multiply and you get a multiple. In the same way, when we're talking factorization, the factor is the noun, and the associated verb is to factorize. You see this word here? Some of you all watching this probably know the word already. So to factorize is the verb. And in the same way that when we multiply, we have a process that we describe as multiplication. That's the process. In the same way that when we factorizing, we have a process. And that process is the process of, all right, let's hear in red now. The process is called factorization. Right? By now, if you were following my videos, you would have a clue as to what factorization is. Factorization is simply a decomposition of any number into its constituent factors. I use some big words and some fancy vocabulary. I do that deliberately just to jog your memory a little bit, make it hit you different. Ooh, big words here, vocabulary. But I'm also going to take my time and explain it. To decompose something means to break it down. That is a term that we would be familiar with from chemistry and all of that. Right? So you take any number and you decompose it. You break it down, so to speak. You break it down into its constituent factors. Constituent just mean that it is part of something else. If you think in politics, you could think of the constituents in a constituency. Right? So the constituency is the number itself, 36. And the constituents are the factors, the constituent factors. Boom. Same thing over here. The constituency is 54. The constituent factors are these numbers here. So my official definition, maybe somebody else use similar language, I don't know, of factorization is the decomposition of any number or any entity or term or whatever it is. Because it's not always numbers that we're breaking down. We're breaking down other things too. As some of you may already be aware. If you're not aware of it yet, you go find out soon enough. But I want you all to understand that factorization as a process is not only applicable to expressions. We could start our understanding of factorization, building straight from our understanding of factors and knowing what factors are. If we factorizing something, it simply means that we're breaking it down to get the factors. So over here, what we have effectively done is to factorize the number 36. We factorize number 36. We have different pairs of factors. And as we get these pairs, we're in a position now at the end to write down all the factors, all the constituent factors of the number 36. We did the same thing with the number 54. We took the number 54 and we factorized the number 54. In other words, we decompose it, we break it down into its factors, into its constituent factors. We went through a particular process by considering one pair at a time, which then allowed us to write all the factors, the constituent factors at the end. Right? Now we're going to go a step further by not just doing a regular factorization. We're going to factorize the numbers into its prime factors. It's a very simple process, you know. Very simple process. Watch. Let us start with the number 36. Again, we start with our good friend, the number 1. So 36 is 1 by 36. No problem. But the number 36 itself, well, 1 by 36, and we know that 36 is 2 by 18. So in place of 36, we could put 1 by 2 by 18. See? So we replace the number 36. Alright? Replace the number green. 36 here is 2 by 18. But 18 is also, listen carefully now, the number 18 is also factorizable. In other words, we could get factors of 18. In other words, 18 is not a prime number. This process here will only end at the point where all the numbers are prime numbers. So 18 is not a prime number, so we ain't finished yet. So 18 is 2 by 9. No problem. We're keeping it simple. So what we will have here would be what? 1 by 2 by 2 by 9. Right? So we run out of colors just now. Eh? So we take the number 18 and we have 2 by 9 here. See? 9 is what? 9 is not a prime number. 9 is also factorizable. Bringing in the vocabulary. Right? 9 is not 2 by anything because 9 is an odd number. But 9 is a perfect square. 9 is 3 by 3. So what we do? We say now that this is 1 by 2 by 2 multiplied by 9 is 3 by 3. What color we have here, boy? Black. We use black here. So we have the 9 here. We take 9 as we express that 3 by 3. That is as far as we could go with the factors. Now you will notice that sometimes the factors are repeated. And we have to do that sometimes because as the numbers get larger, then yeah, you have to repeat the factors. It's not a simple case like 10, which is 1 by 2 by 5, which, let me do that one time now. Consider the number 10. Alright. Hey, we didn't use red across here. Very nice. Consider the number 10. 10 is 1 by 10. 10 is also 2 by 5. Story done right there. Ha! Right? Let me try 15. Well, you'll get out with most multiples of 5. Well, except 20, because 20 is 4 by 5. Let me do 20 just to drive the point home. Consider 20. 20 is 1 by 20. 20 is 2 by 10. 10 is 2 by 5. Alright? So 1 by 2 by 2 by 5 is 20. If we had done 15, it would have been 15 is equal to 1 by 15, and 15 is 3 by 5. So 10, 1 by 2 by 5, prime factors. 15, 1 by 3 by 5, prime factors. 20, 1 by 2 by 2 by 5. So you have a repeated factor here. So as the numbers get bigger, you will find yourself having to repeat the prime factors, and that's another issue. Who said there's a problem? Anybody say there's a problem? No, that's not the issue. I'm coming close because I'm watching the camera there, right? I'm watching the technology. 36, however, being a kind of biggish number. Biggish, relatively speaking, of course, right? You find that we have two sets of repeated factors. We have the 2 repeated and the 3 repeated. And there's a day now. There's a day. There's a day. Now, there's another way we could write this, which I will put here just for the record. We wouldn't discuss it now because before we do that, we have to delve into a whole separate topic by itself. That is the topic of indices. It's another serious topic. But we can't talk indices if we don't have a basic understanding of certain aspects of numbers. Alright? So watch it very carefully. 36 is 1. 2 by 2 is 2 to the power of 2, which is 2 squared. And 3 by 3 is 3 to the power of 2, which is 3 squared. We leave it like that. We wouldn't go further. 10 is 1 by 2 by 5, so we don't need that here. 15 is 1 by 3 by 5, we don't need that here. But 20. 20 is 1 by 2 by 2. 2 to the power of 2 by 5. See? So in other words, we have the prime numbers themselves written out, but if we write it in this form, we have the prime numbers raised to a particular power. Again, I'm using the language because we haven't really gone into indices in any great detail as yet. We'll come to that soon. So stay tuned. So 36 is 1 by 2 by 2 by 3 by 3. 1 by 2 raised to the power of 2. In other words, 2 multiplied by itself twice. And 3, well, 1 by 2 by 2 and multiplied by 3 by 3. Hold on. Let me slow down here now. 36 is 1 by 2 by 2 by 3 by 3. 1 by 2 by 2 can be expressed as 2 raised to the power of 2. And 3 by 3 is 3 raised to the power of 2. 3 multiplied by itself, 2 multiplied by itself. 20 is the same thing. 1 by 2 by 2 by 5. 1 by 2 squared. 2 by 2 is 2 squared by 5. Again, we leave that alone for now. Let us now finish this discussion by going back to the number 54, which we also had as an example of the whole question of getting a number, finding the factors of a number. So we said, watch it again, watch the procedure. It's real nice, you know. It's nice like spice, as I like to tell my people. Alright? So 54 is 1 by 54. No problem. So far, so good. 54 is 2 by 27. So 54 is not a prime number. 54 is factorizable. So we factorize 54. 54 is 2 by 27. So we take this 54 and we express it as 2 by 27. But 27 is also factorizable. We know 27 is 3 by 9. 1 by 2 by 3 by 9. So we take this 27 and we express it as 3 by 9. But 9 itself is factorizable. Not being a prime number, we know that 9 is also a perfect square. So 9 is 3 by 3. So 3 by 3 would be, I'm just making sure this mic in place. So this will be what? 1 by 2 by 3 by 9 is 3 by 3. So the 9 is, let me go green. So 9 is 3 by 3. So that we at a point here now where all of the numbers in the multiplication are prime numbers, so we can't really go further than that. So here 54 at the end would be 54 is equal to 1 by 2 by 3 by 3 by 3. And of course, if we're using the notation of indices, powers, yes, we'll deal with that in other videos. That will be 1 by 2 by 3 to the power of 3. And is it right there now? That is it right there. Right? 3 by 3 by 3 to the power of 3. You see how nice it is? You didn't realize it was so nice, huh? That's why we're here. We're here to fix that. Nice? So, I trust and I hope. I'm going to mic there just now. I trust and I hope that you have looked at everything that I would have had to say on multiples, factors, and primes. I hope that you would have enjoyed it, and I hope that you're beginning, if you haven't had that sense before, that you're beginning to sense that the mathematics is doable. Doable by the nature of the word suggests a certain level of effort. So it's not going to fall in your lap. But that doesn't mean it can't be done. Some days will be harder than others, like in every other endeavor. But the hard days are not an excuse to have no days at all. Right? So I just want to encourage you, whoever you are watching this, whatever level you're at, wherever you are on the mathematical scale, as me cracking my fingers, you could do it. Just commit to making the effort and making the time. So stay tuned. If you're seeing this video on the YouTube channel, like the channel, click the subscription, click the notification, subscribe, so that you could get your notification whenever we upload anything else. If you're watching it on Facebook, do the same thing. Like the page, subscribe to it, like the page, and then click the notification so that you could be aware, you could be made aware anytime we have new content. So stay tuned. We have plenty more coming. Boom!